Okay, number 5. We have a basketball player exerts a 3,225 Newton force upon the gym floor in order to accelerate his body upward. So look, Newton's third law, I know you know it. Every force has a equal and opposite force. So this is, I don't know, we haven't had a problem like this before, but here's how you do it. So he exerts a force of 3,225 newtons upon the gym floor. So what's the force that the floor exerts on him? The same force. So, you know, it's kind of like if I push on the table with a 10 Newton force, the table pushes back on me with a 10 Newton force. Every force has an equal and opposite reaction force. So the force of the floor, which, by the way, what's the force of the floor called? What do we call the force of the floor acting on him? That's called the normal force. So the normal force on this guy is 3,225 newtons. Okay, and then the downward force is his weight, which is mg. And we know his mass is 76.5 kilograms. Let's say that up is plus and down is minus, like that. So what do they want us to find? His acceleration. So you sum the forces. Which way is this guy going to accelerate if he's jumping upward? He'll accelerate upward. So we go normal force minus mg equals ma. And we're solving for a. So his acceleration is going to be
Are there like two downward forces then?
No, just one downward force.
So the downward force of 3,225.
Oh, well, that would be if we were doing a free body diagram for the floor.
Okay.
See, the basketball player, he exerts a force down on the floor. So what does the floor do back to him? It exerts a force up. So the force would not, the 3,225 Newton force would only be drawn as down if you were doing a free body diagram for the floor. So we're doing our free body diagram for the player. Okay, so that's what the algebra looks like. So normal force is 3,225 newtons. His mass is 76.5 kilograms. Gravity is 9.8. So we're just plugging into this equation. And then mass is 76.5. So this gives us an acceleration of 32.36. Okay? So we now have his acceleration. Let me put that here. Acceleration is 32.36 meter per second squared. Okay, part B. So can I erase this? Okay, part B is a kinematic. So we're told that the time of contact between him and the floor during his jump is 0.15 seconds. So we'll use one of the motion equations. Use this motion equation. V initial is 0. So V final is going to be A times T. So 32.36 meter per second squared for a time of 0.15 seconds gives a final velocity of 4.85. And then the last question, what's the net force? So two ways you could do it. First possible way to find the net force is you could simply just go F net equals what? MA. So that's 76.5 kilograms. His acceleration is 32.36 meter per second squared. So that gives a net force. Remember, net means total. That gives a net force of 2,475.3. Now, what's the other way you could have found the net force? Well, look, we know the normal force. We have that force. mg we can calculate. M times G is 749.7. Look, which force is going to win? We have an upward force of 3,225. We have a downward force of 749. What's the net force going to be? The difference between them. Think of it like a tug of war. You know, we have an up force that's bigger than the down force. So how do we find the net force? Subtract them. Subtract them, and it's going to give you this. Upward. The net force is upward.